We are continuing on with our AI Combinator Hackathon entry to do code generation. We're moving on from installing the prerequisites to this Jupyter notebook for deploying microservices. So we're going to let this open up here. I'm going to click on it again for good measure. So we're going to deploy Fireware and Smart Village microservices. Fireware is open source standards for IoT data. They've come up with hundreds of smart data models that match smart devices around the world, used around the world. And you can plug into the Fireware community and use those smart data models. And they're microservices that are containerized and run in Red Hat OpenShift very well so that we can leverage the Fireware community's work in edge device technology. And Smart Village was a project I've worked on for the past 2 years with the Red Hat Collaboratory with Boston University. That's really cool. We were developing smart traffic lights and the standards around building smart traffic lights. So we're going to plug into that as well. What we do to get started is cloning the Smart Village operator. So right now we've cloned the Smart Device API Generation Hackathon repo. Now we have the Smart Village operator repo with all of its Ansible automation to deploy Fireware and Smart Village components. So let's start with the first one, which is a MongoDB NoSQL database. So this is required for Fireware IoT agents to store smart device registration data for each smart device in the project. And I'll show you that data later on. We run this playbook and then let's check on our pods here. Yeah, in fact, I want to put these side by side so you can see what's going on behind the scenes. As we run this stuff. Maybe I'll make this a tiny bit shorter since we don't need a ton of space there. Okay, that looks good. Cool. So this is running, and if we check this right here, it says the pod's running, so we can move on to the next step. In fact, I'm going to run all of these and we're just going to follow along. Watch how fast we can deploy everything now. So we're going to run, let's see, we're going to run the Ansible playbook again for MongoDB, and now it's done. It checks that the pod's ready, and then it moves on to the next. So now we're deploying RabbitMQ. RabbitMQ can receive messages from smart devices and forward them onto an IoT agent to process that message. So over here, you see RabbitMQ is creating a container, a pod, and this is waiting for RabbitMQ to be ready. So it's running now. It's not quite ready yet. Let's see if we can see that ready status. There we go. So 0 out of 1 readiness checks are ready, but in just a moment, we should see it become ready and move on to the next task. RabbitMQ is ready now. It's running. Now it will move on to deploying PostgreSQL. So PostgreSQL is required by the Scorpio broker to store smart device context data for each smart device. We also store configurable user data like traffic simulations, simulation reports, and more in the Smart Village application with PostgreSQL. So it's shared between 2 different services. So now we need PostgreSQL to be running for the next step. It's running. Now we're going to rerun that Ansible playbook because the pod's running and we can create the database schemas automatically and initialize our PostgreSQL database like it's doing here, run the SQL scripts on them to create those table schemas and get everything ready. So that is successful. PostgreSQL is running. Now we're moving on to the Scorpio broker, which depends on PostgreSQL to be running. So this is now creating, you see Scorpio broker running, and it should become ready any moment. Scorpio broker is ready and running. Now we can deploy the IoT agent. I forgot to explain that the Scorpio broker is a fireware context broker required for storing smart device entity data about the vehicle traffic cameras and pedestrian traffic cameras we have set up in the project, or other smart data that you have. It can store that data as well. The IoT agent is also a fireware component that is required for smart device registration of the vehicle traffic cameras and pedestrian traffic cameras. The IoT agent doesn't store the data of the traffic camera, but it's the messaging agent that receives and sends messages to the traffic camera or from the traffic camera smart devices. Now we're getting into Smart Village components like Apache Zookeeper. It's required for distributing messages and workloads to multiple pods of the reactive asynchronous microservices like Apache Solr and the Smart Village platform. Basically, a message on the event bus can be received and sent to any of the pods, so you can scale up the number of pods and be able to handle more and more messages coming in from Zookeeper. It's clustered. It's a clustered manager. So we're watching Zookeeper start up here on the left. It's running. We just need it to be ready. And now it's ready. Now we can deploy Apache Solr, which is required by the Smart Village application API to serve up API objects as quickly as possible. APIs that are backed by a search engine have numerous additional benefits compared to an API backed by a traditional relational database, because a search engine is always indexed for the fastest data retrieval possible, and there's advanced data and query parsing of search engine data that allows for extremely fast full-text search, filtering, and sorting on the data. You can group, facet, pivot, and do all kinds of advanced search and analytics and statistics on your data. So let's see if Apache Solr is running. It's running, yay. So now we're moving on to, we're going to create the Solr collections and config sets that are required. So that's done. Well, it's working on that. It's creating the Solr collections now that the pod is running. And then now that that's complete, we're going to create the Smart Buyer Smart Village platform, get that up and running. So we deploy an auth secret. This auth secret is related to Red Hat single sign-on authentication, OpenID Connect OAuth 2. And it allows GitHub users to access their own version of Smart Village in their own cluster and get role-based access control to that and test out the data. So we deploy that auth secret, then we deploy the Smart Village platform and wait for those pods to start up. The Smart Village platform is for is used by researchers to configure smart devices for improving traffic light configuration and running reports on traffic simulations configured at intersections in the world. Vehicles and pedestrian traffic is what we're interested in the project, but the Smart Village platform allows you to deploy any kind of smart data model you want. You can even create your own custom ones like we did and get them up and running quickly with code generation that we're showing in this hackathon here. We just need these containers to be running and ready. And the Smart Village platform integrates with all the other microservices that we've talked about today for a complete edge-to-cloud solution to send your data to a message broker like RabbitMQ. The message is received and sent to the IoT agent. The IoT agent takes that data and turns it into NGSI LD format, a format for sending smart device data to a context broker. The context broker goes and stores that NGSI LD data and information about its context, which is basically documentation about your smart device. And then we can subscribe to any updates to entity data on the context broker. And that's what we do with the Smart Village platform. We have an NGSI LD Smart Village Sync application that subscribes to entity data changes. And so when the context broker says, hey, this smart device data was updated, our NGSI LD Sync gets sent the updated data, and then we can take that data at the edge and send it to the cloud through our role-based access control provided by Red Hat single sign-on securely with the secrets. We can send that data to the cloud and do additional cloud processing on that edge data. So that's what it's about. Our Smart Village platform and FiWare platform is up and running. All the components are up and running, as you can see here. So next, we're going to move on to the next notebook, which is code generation. So that's the end of this video. Thanks for watching.